Review of things that we have covered. I love this website. Math is fun. Well, for one, because I am a nerd and I like math, but also just because it takes things and makes them really simple to understand. So just going to go over a few probability ideas. So first of all, probability, very simply stated, is just how likely something is to happen. So here's a few examples. When a coin is tossed, there are two possible outcomes, heads or tails. We say that the probability of the coin landing on heads is 1/2. Now, we could also say that this is 0.5, or we could say that this is 50%. Now, I want everyone to be very ready to type in our chat box today because I'm going to be asking just a ton of questions, and I'm hoping to get through the questions quickly. So I need everyone to be ready. Keep your hands on the keyboard. This probability, it says, we say that the probability of the coin landing on heads is 1/2. Will you type this in the chat box, whether you think this is theoretical or experimental? There's two types of probabilities we talked about. Even if it's just a guess, what is your guess? Is this theoretical probability or experimental probability? Theoretical, theoretical. You could even put T or E.
Yeah. Or theo or exp.
That is not an option, Emmanuel, sorry. So theoretical or experimental. I'll give you 3 more seconds. 1, 2, 3. Okay, so yeah, this is theoretical probability. And we'll go more into that, but I'm just letting you know this is not experimental, this is theoretical. Same thing with tails. Theoretical probability of landing on tails is 1/2, or you can say 0.5 or 50%, or you can also use that term that we've said before, as likely or as unlikely as not. Either way, as unlikely as it is likely.
There's only 2 options.
Yep, same chances for each of the 2 possibilities. Okay, now throwing dice. These are 2 things that have fair outcomes. So there's 2 clear options with a coin, and there's 6 clear possibilities with the dice. With a die, we have 6 possible outcomes, 1, 2, 3, 4, 5, and 6. The probability of any one of them, so if you, before you roll, you know that the possibility of getting a 1 would be 1 out of 6. The possibility of getting a 5, that's also 1 out of 6, because we only have 1 5. There's only one way to get a 5, and that's to roll on that one side of the die. So this is also theoretical probability. Let's keep going kind of quickly through this. Examples of rolling a 4. There's only one way this can happen, and since there's 6 possibilities, it's 1 out of 6. We're going to do a couple examples like this today. Different colored marbles in a bag or in a box or something like that. If we have 4 blue, 1 red, what's the probability that a blue marble is picked? So if there's 4 blues, then we have 4 different ways that we can choose a blue. We could choose the first blue, or the second blue, or the third blue, or the fourth blue. And there's 5 total because there's 1 extra red, meaning the chances of us getting a blue is 4 out of 5. And here's some vocabulary that we've gone over to talk about different probabilities or likelihood. Certain, meaning it's for sure to happen, is 100%, or the number 1. Probability is always from 0 to 1, or 0 to 100%. Even chance is 50% or 1/2. And then everything else in between those is a decimal or a fraction or percentage that's in between 50% and 1, or in between 1/2 and 0. Doesn't, the fraction, the decimal, doesn't matter which you choose to explain it with. Okay, and probability does not tell exactly what will happen. It is just a guide. This is talking about theoretical probability. If we toss a coin 100 times, how many heads will come up? Probability, theoretical probability, says that heads have a 1/2 chance. So we can expect 50 heads to be flipped, but that's not always what happens. So that's why we have experimental probability to, after we do an experiment, track the probability of and the amount of events that have happened, or basically keep track of what happened during our experiment.
Mr.
Yeah. Yep.
You're in a beach.
Oh, sorry. It's just a background. Mr. E, what did you want to add to that?
Will you scroll up just an inch?
Yeah.
So
That's my math.
just kind of reiterating what Mr. A guys said, guys, is that like it's probability, so it's not going to be for sure. It's not a for sure thing. So if, like he said, if you flip a coin 100 times, like we know that flipping a coin is 50-50, but it's not a precise thing. It's like a chance, right? There's still some probability to it, some chance. So things don't always go as expected or theorized. That's why we call it theoretical. So I just wanted to kind of add some visual.
Yeah, sure. If anyone wants to look at this website, which it'd probably be good to revisit, this has a lot of good information. I just shared it in the chat box. We're going to go ahead and end our short review and get into our slideshow for today. So hopefully everyone has this open. Mr. E has shared it a couple times in the chat box already. So if you don't have that open, please open it right now as we get started. Our objective today, I can solidify my understanding of the differences in theoretical and experimental probabilities and know when to use each. So by the end of today, we need to be able to tell what the difference is and good circumstances when we would use different types of probability. So let's look at our first example here. I'm going to go ahead and go to this. There we go. All right. At a school fair, you have a choice of spinning spinner A or spinner B. You will win an MP3 player if the spinner lands on a section with a star in it. So we have spinner A and spinner B, two spinners. You will win an MP3 player if the spinner lands on a section with a star in it. So we used to call them MP3 players. You probably just call them like Hey, Anthony, could you mute your mic, please?
I haven't taken it.
You haven't?
All right, I'll do it for you.
Thought.
Or maybe Mr. E can.
Just kidding, bro.
No, you have to sign up.
No, you don't.
With Google?
Can you mute him?
Nice.
No, just put the X right there.
You call it Spotify or SoundCloud. Okay. Well, some sort of device where you can listen to music. I know this is not as common, but basically just think that you are winning something. Maybe it's a lifetime supply of Takis, and you have to choose which spinner you want to spin. So before we figure out the probability and the outcomes and all that, I want you to type in the chat box. Just looking at the spinners, which one would you choose? Which one do you think has a better chance of winning based on the stars? Is it spinner A or spinner B? You're choosing one of these spinners to spin. Which one gives you a better chance of winning the prize. I see 3 stars on spinner A and 5 stars on spinner B. Everyone's putting A. You think they're the same? Okay. Still A. A. All right. We'll figure out which one is better or if there's a difference. Awesome responses. So, total number of outcomes. And I would like you to fill this in on your slideshow as we go. Hopefully you made a copy so it actually allows you to type in the text boxes. So spinner A, the total number of outcomes, that is how many different spaces we have on our spinner. 5, 6, 7, 8. We have 8 possible outcomes. So our next one, number of sections with stars. I already said that. We have 3 different sections that have stars on them. So the probability of landing on a star, or the probability of winning an MP3 player, is the number of sections over, nope, I'm sorry. The sections with stars over the total number of sections. So the probability of winning an MP3 player is 3/8. Or if we want to write that in a decimal or percentage, 3 divided by 8. The percentage for that spinner is 37.5% chance. Okay. So, everybody, what do we put in this box right here? Look at spinner B. What is the total number of outcomes? You have to count each one of the sections. You can number them like I did. Start in one spot and then count going around. What's the total number of sections?
I don't know if they're can see where you're pointing to.
It's spinner B. This spinner, this box, star right here.
It's not showing up.
Oh my goodness. Why is this not sharing? Huh. Let's try again. Share screen. Screen. Share. Ha.
Ah.
That would have been good to know. Okay.
Oh, wait, someone else?
Yep, that was Anthony.
Okay.
I'm gonna need you to, okay, there we go. Okay, so, sorry you guys couldn't see that. I should have, whatever. So what I'm asking is this box right here.
Oh,
Okay.
I'm sorry, that was me.
Oh.
Yeah.
All right, so let's try again. This box right here with the star in it, what is the total number of outcomes for spinner B? Total number of outcomes, total number of sections on the spinner.
So count them up. How many are there?
And put it in the chat box. Ready, go. Put your answer in the chat box. Thank you, Briggs. Emmanuel got 15, Cadence 18, 19.
A couple more answers real quick. 5, 4, 3, 2, 1. Okay. Okay, it seems like 19, 18, 17, 16, somewhere around there.
I'm going to count half of it because it looks like it's split down the middle. And since we have two halves, I know that we're going to have 16 total spaces. There are not 300. You guys are crazy. I'm about to write 300. 16 total spaces. All right. Now, next box. Please do this quickly. Write it in the chat box. What is the total number of sections that have stars in them for spinner B? Total number of sections that have stars. Nice. Yes. Awesome. Everyone got that. It's 5. We have 5 stars. So then our probability for that, go ahead and put in the chat box. What is the fraction we would use to find the probability for spinner B? Very nice. It's the number of sections with stars over the total number of outcomes. So let's put that in our calculator. 5 divided by 16. Probability for spinner B is 31.25%.
Probability of spinning a star, having it land on.
Yep. Probability of spinning a star is 31.25%. So everybody in the chat box, which spinner would you choose if you want a better chance of winning? Yeah. We would choose the one that has the higher percentage. Okay.
More likely to happen.
Yeah. All right. Honestly, I think this is a good slide to have to talk about. I want to get into some of our examples though. We'll talk about this stuff as we go. So, theoretical versus experimental probability.
Good.
What was the last answer? The last answer on this one? A. Okay, everybody go to this slide. Theoretical versus experimental probability. And if you want to just watch, that's fine as well. Okay. A bag of marbles has marbles that are red, yellow, and blue. Jeff wants to find the theoretical probability of drawing each color of marble before he does an experiment with the marbles. Okay, so we've got 3 colors, red, yellow, and blue. Red, that's not really red. Yellow, and blue. Before we do an experiment with these marbles, we want to find out the probability of pulling each color out of the bag. So the probability of red, that's our first one right here. Like we just found out, we have to do the number of ways the event can occur. So for red, I'm going to go ahead and show you all the ways this event can occur. Red, we have 1, 2, 3, 4, 5 marbles. Yellow, we have 1, 2, 3, 4, 5, 6 marbles. Oh no. Go away. 6 marbles. And blue, we have 2.
Hello.
Huh. Blue and blue. Okay. So if you were to count up each one of these, let's say these were each a marble, count up each one of those, what is our total number of marbles? Will you put this in the chat box? Go ahead and put it in the chat box. What's the total number of marbles in the bag? We have 5 red, 6 yellow, and 2 blue. Everybody type. Type a number and press enter. Count them up. Total number of marbles in the bag. Thanks for everyone that has their mic off and they're participating in the chat. It makes
You're
this so
welcome.
much better. Awesome. Yep, our total is 13.
Great job, guys. Good.
So we have 13 marbles. What happened here? 2 blue, okay. And to find the probability of each one, we have to put how many there are over the total number of outcomes. So that means the bottom part of our fraction for each one of these will have 13. So if you draw one marble, you'll be drawing 1 out of 13. And each different color will have a different theoretical probability. So I'll just do red for you. We have 5 red out of 13 total, so our chances would be 5 out of 13. Go ahead and put it in your slideshow, the yellow and the blue. And in about 15 seconds, I'm going to ask you to put one of your answers in the chat box. Don't put it in there yet. I'll tell you which one I want. Yes, you have to, Carl, the goat. It's a requirement.
So they're figuring out the yellow one now, but not posting it, correct?
Correct. Fill out the yellow and blue.
All right, guys. So there shouldn't be that much chatting because you guys should be trying to figure out what the probability of drawing a yellow marble is and a blue.
I should have used this one. All right, hopefully you have yellow already. And really all you're doing is pretty much duplicating what I did for red, just using the different numbers. For red, I used 5. So for yellow, use 6.
Mr. A, do you want to draw like a little stick figure bag around your oranges? I mean your red.
Oh yeah. This is my bag of marbles.
So if those are all marbles in a bag, what's the probability of drawing a yellow one?
Okay. Go ahead and put your answers. What's the probability of drawing a yellow marble from the bag? Probability of drawing a yellow marble is equal to, thank you, Cadence. Thank you, Pablo. Thanks, Briggs.
Yep, looks like you guys are getting it. It's gonna be 6 out of 13. Got 13 total marbles, and 6 of them are yellow.
And hopefully you already have the answer for blue. This is 2 out of 13. Same total of marbles, 13 in the bag. But
Mr. A, where are you?
There's only 2 blue ones. If you want to ask a question, you can ask it in the chat box, or you can also...
I have, but you weren't answering.
Did you say, where am I? I thought you said, what am I?
No, where are you?
I'm in my basement. This is a fake background.
How do I put one?
Oh, it's a green screen.
Why
Alright,
did you
guys.
put a fake background?
Okay.
You can ask more about the background in a minute, but not right now.
I'd love to teach you guys later after we talk about probability.
It's a green
So-
screen.
So the probability for each one of these marbles in our bag of 13 marbles is right here. It's shown by writing P parentheses red parentheses equals 5 out of 13. And same thing for yellow, same thing for blue. Just different numbers, different words. Okay, so that is our theoretical probability. Now, like it says, Jeff wants to find, Jeff is going to do an experiment. So if you go into the
I have another
next,
question.
can you, is it about this slide? If it's about this slide, I'd love to answer it. But if it's about something else, will you save it?
It's about the first slide. Were we supposed to type that?
Mr. A, which slide are we on? Are we on the 5th?
This slide?
Yeah.
You can type that, yeah. But really, don't worry too much about it. As long as you're following along and understanding this, we're going to have something that you're going to turn in later. But for right now, we got to make sure everyone's on the same track. Okay, everyone, please, if your mic is not turned off, we have, I think, too many mics on right now. It's taken away from our lesson. I want to say thank you to everyone that has their microphones off. And you should be on this slide right now, theoretical versus experimental probability. So we just found the theoretical probability. Now he's going to do an experiment. He's going to pull out different marbles, and it looks like if we add these up, he has pulled out a total of 20. I didn't want to use that color. He's pulled out a total of 20 marbles. He pulled out 10 red marbles, 14 yellow marbles, and 6 blue marbles. So our experimental probability is going to be based off of the results from his experiment. So let's look at this purple border image here. The probability of an event in this case would be pulling one red marble out of the bag. That would be an event. The probability of pulling a red marble out of the bag based on his results is what we're going to figure out right now. So the probability of pulling a red marble out of the bag is based on the observed frequency of the event, the top part of our fraction. So everybody type in the chat box, what is the observed frequency? And actually I'm going to give you this one so we can have you do yellow and blue. What is the observed frequency of red is 10, and then the number of observed attempts, he had 20 total attempts. So it's 10 out of 20. So out of 20 times of pulling a marble out of the bag, he pulled 10 reds. So the experimental probability, or the results of his experiment, would be 10 out of 20, or 1/2. So half of the time, he pulled a red marble out of the bag. All right. If you are following along, I would love for you to type in the chat box and say what the experimental probability of pulling a red marble is. What is the experimental probability of pulling a red marble out of our bag of marbles? Thanks, Emmanuel. Good, Pablo. Thank you, guys. I can tell who's following along. So it's not just 10. That's how many times he did pull a red marble. But we're asking what is the experimental probability. So based on his experiment, what's the probability that he would pull another red?
Mr. A, if I may.
Yeah.
So guys, the important distinction between these two examples, the last one and this one, is the other one, we knew exactly how many marbles we had. Okay. And we were saying, what's the probability if there's like, 2 blues out of the total, 13 marbles. But this one, we don't necessarily know how many marbles we have, but we know that they did 20 draws out of the bag, if you can see my picture. They're drawing marbles out of the bag 20 times, and out of those times, 10 of those happened to be red ones, 14 of those happened to be yellow ones. So we're trying to come up with a probability of, oh, there might be this many, or what's the probability, the chances of drawing a red when this happened in the past. So does that kind of make sense, hopefully?
Yeah, so I actually was thinking we would have, this is the same marble. This is some guy named Jeff. He has a bag of marbles. We found the chances of pulling these different marbles out of the bag. And then he did the experiment that we're talking about. He pulled 20 times, he pulled a marble out of the bag, and then these were his results.
Mm-hmm.
Based on his results, we want to find the probability, and not based on theory, not based on how many we have in the bag, based on his results.
Right.
That's the main difference between theoretical and experimental. Experimental is based on the results of an experiment.
Yep.
So
that's the difference.
All right, everybody, this is super easy. Everyone should answer. Type in the chat box, how many times did Jeffrey pull a yellow marble out of the bag? Awesome. Okay. And I'll ask this again. How many total times did he pull a marble out of the bag? The total amount of times that he pulled a marble out of the bag.
How many draws did he do?
How many draws? Sure. Probably a better term. Got a variety here. If we pulled 10 reds, 14 yellow, and 6 blue, that's a total of 20 times that he drew a marble or picked a marble out of a bag. That's our total. So for yellow, go ahead and write our experimental probability. Okay, guys, the chat box, it has a purpose. I'm sorry to have to do this, but we are taking away from the purpose of this meeting if we're doing nothing but messing around in the chat box. I know you guys probably miss each other, and I understand you want to chat. It would be awesome if you could set up a chat after this or when you do not have a class. But right now there are people here that are trying to learn, and it's already hard enough. We have things going on that are out of our control. We need to use the chat box and our microphones. They have a purpose, and we are taking away from what we're supposed to be doing right now. So please, guys, let's keep our chat only relevant or on topic with what we're talking about.
And if you have a question, feel free to post in the chat, and I'll answer it, or we'll pause and let you unmute. Okay. But anyway, yeah, we've already had one person kicked so far. So be responsible. That way you can participate in class. Okay. So we're about to have you guys do an experiment, but if you're not paying attention, you won't know how to do it.
Okay. So the probability, experimental probability of pulling a, we're going to move on from red and talk about yellow. What is the experimental probability based on his results of picking a yellow marble out of the bag?
Hey guys, so what do you think? The probability of picking a yellow out of the bag if we're just going off of the experimental probability. They did 14 draws, or sorry, 20 draws total, and 14 of them were yellow. So what's the probability? All right. 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. What'd you guys get? Oh, I had someone put it as a percentage, 70%. 70%, 15 out of 20, 17 out of 20, 7 out of 20. So if we got 14 yellow marbles out of our 20 draws, that means it's a 70% chance. Good job there, guys.
Very nice.
At 20.
We could say 0.7 or say 70%. So this means that 70% of the time, 70% of the draws or times that he reached in the bag to get a marble, 70% of the time it was a yellow marble. And next one.
And last
So
one.
move on to blue. All right. What is the experimental probability of pulling a blue? So based on these results, what do we put in the box for blue? Out of a total of 20 times.
Go ahead and start putting your answers. And you could even do it as a simplified fraction too. Like on that last one, 14, 20, we could say is 7 out of 10. Good, Cadence. Good, Preston. Got a couple answers. Anybody agree or disagree? Post in the chat.
Remember, he only did it total of 20 times. So the bottom of our fraction will be the total amount of times that he took a marble out of the bag.
Right. So he when he drew 20 marbles out of the bag, 6 of them, he said, oh, 6 of these are blue. So what's the probability based on the experiment? What's the probability of drawing a blue? All right, 5 seconds. 4, 3, 2, 1, and 6 out of 20 is our answer.
There are different ways we can write it. 6 plus 14 equals 20. Oh my gosh. So I've seriously.
I didn't get that.
Ha!
Good, Briggs.
I'm so sorry. Thank you. Oh my gosh. I'm gonna go through and do that. Man. I am sorry. Wow. Good catch.
And anyway, not to hammer home on anything. Part of the reason we want to go fast because we want to, like, you know, if you're like, oh, we get it, it's easy. But also, that's another reason why this chat needs to be focused, which it is now. It's going well, is so that way people can say, hey, I don't understand, or what's going on. So good catch there, guys. So it was actually 30 draws, right? That's what Briggs pointed out. Thank you. So that just means that the first one would be 10 out of 30, 14 out of 30, and that will change our percentages, right? And 6 out of 30. If one of you guys has a question, you can post it in the chat. Or if you type mic, then we'll let you unmute your mic and you can just ask if it's a longer question.
So by this point, we should at least have a basic understanding of the differences. Theoretical probability is without having an experiment done, we just know we have a certain amount of marbles and some of them are this color, some are this color. What are the chances of pulling a certain color based on the total number of marbles? Okay, that's theoretical. We're making guesses basically about what is going to be our results. Experimental is after you have done that, after you go and draw a marble out of a bag, this time he did it 30 times. 30 times he picked a marble out of the bag, put it back in, and kept track of how many times he pulled each color. So he didn't do these in order. It's not like he pulled 10 red ones and then he pulled 14 yellow ones. Instead, this is just a tally, a total. So he could have started by pulling a blue one and then he put it back in and drew a yellow one. And these are the results, the total number of marbles that he's pulled of each color of marble. All right, we're gonna do a little application here. So this, in case you don't have the Google form, you can go ahead and click, no, I'm sorry, it's not a form, it's a Google Draw. Go ahead and click on this link in your slideshow, and it will take you to this Google Draw where we're gonna do an activity. So for the activity,
And sorry, real quick. And I don't know, they may have linked this. So mine's just in the slides. So my class, if you're in the slideshow, that's where you'll click on the click here button to get the link.
oh yeah, mine's in the links.
Okay.
It's linked. Okay. So your task, find a trash can and a piece of paper, crumple the piece of paper into a nice round ball, take 5 steps away from the trash can, shoot your paper ball at the trash can. Okay, so what we're doing basically is playing basketball, but we know that not everyone has a basketball hoop. Not everyone has a basketball. So instead of that, we're gonna do trash get ball. So with a piece of paper, you're gonna see how many times you can make it into a trash can. So I'm gonna give everyone, let's move on and not move on, but let's start this activity in like 2 minutes. I think everyone can find something, even if it's not a trash can. Maybe it's a mixing bowl. Maybe it's a laundry basket. Anything you can find that you want to.
So go ahead and do that, guys.
Yep, go ahead and grab. A trash can is good for this because it's a good size. Let me show you what I have.
Go get a little trash can and a piece of paper that you can crumple up and come back. Mr. A's got a great example of one. So.
Yeah. I'm going to turn off my beach background. Okay, so I have this bucket here. Bucket. And I have a ball. You can use a piece of paper, you can use a ball. And Mr. E's got a bowl. The goal is to put this somewhere on the ground, take 5 steps away, and see how many times you can make your ball, whatever it might be, into your garbage can or bucket or whatever bowl. You're going to take 10 shots, and you need to keep track of the results in your Google Draw. So we have this Google Draw. Name. You put your name up there. You'll keep track of shots made and shots. Oh, okay. We're supposed to fill this in with them?
I think they can all edit it, right?
Oh, okay.
I don't know. Shots attempted should all be 10 though, so it's confusing.
Yeah, I don't think I have it so they can edit.
Right. Let's go ahead and have, you guys can go ahead and start. Let's say go ahead and set up your thing, take 5 steps away, and then take 10 shots and keep track of how many that you score. Okay?
Whoops.
Give me 1 sec, Abigail. I'm gonna see if I can change it. Or did you already change it, Mr. A? To editable.
What's that?
Is it editable now?
Yes.
Okay.
You might have to refresh it. So I'm going to keep this open. You guys can go ahead and, yeah, put your name in there. You can choose any of these spots.
Yeah, there's no order.
I'm going to make my 10 shots right now.
How do you type? It's not letting me type.
I'm going to go ahead and put the link
How do you like
in the chat
type
box.
in it? It's not letting me type in it.
Try to refresh. Let's do it. All right, I'm gonna take my shots. See if I get some scores.
Okay.
There's the link, Emmanuel.
Heavy traffic. Bruh.
Oh. Nice.
Try again. Ooh.
See if I can set it up so you can see my shots. All right.
It's not
Oh.
working. Am I working? Oh, yes, it is. Okay. Ooh. Ooh.
Nice.
Oh, those trick shots, though. Ooh.
All right, I've got 3 out of 5 so far. How are you guys doing? Ooh. Oh. Okay, I only made 5.
So are we supposed to like type anything in the slides, like, or do we just have to like understand the concept?
The slideshows are, for the most point, just so you can share it with me, and so I can check to see if you're understanding, and also kind of following along.
It's easier to also write and think and do rather than just to listen, of course.
I don't know, Carl the Goat. Who are you?
That's Carl Manawatu, I think.
That's
that's
your
Carl.
Carl? Okay. I don't have a Carl, so I was wondering if it was just a made-up name.
Here, I've got a theory. I'm gonna try this. Okay, if you aren't able to edit, try this link in the chat, okay? It's coming right here. You're gonna have to copy that and paste it.
Is that Callan?
Alan?
Callan? Is it as likely or not? If you made 8 out of 10, that's in between. It's more than half, so we know it's not as likely as not, but it's also not certain because you didn't make all 10. So it's somewhere in between as likely as not and certain. Yeah, there you go, likely. It is likely that you would make another one. As long as it's more than half, Oh, I wonder if I should have.
Okay.
Um,
Here's a shorter URL to the same thing, same website to edit, guys.
I'm gonna go ahead and put in a percentage for mine.
Make sure that you put in your score, guys, of how many baskets you made. That way you can get a.
Yeah, I misled you. Let's not write the vocabulary like as likely as not or likely. Let's write the actual percentage. Very nice. Briggs made all 10.
What? That's crazy. We got some ballers in here. I only got 6 out of 10. The bowl I was shooting into was a little unforgiving.
Hey, Anthony, I think you're typing over Carl, or maybe one of you. Will you guys choose different boxes? Make sure you have your own box.
There you go.
Awesome, awesome. Nice, good job, everybody. After you're done with this, there are 2 more slides that I'm going to ask you all to read through and answer the questions that are on the slides. There's 2 questions, and I want you to think about those questions and answer them. And next time we meet, we will go over these 2 questions to start us off. That'll be our starter for next time. We'll talk about these questions and some of the answers that you guys found.
And
If that's cool with Mr. E.
yeah. And we're going to look at, you guys remember how we had you do the coin flips and the spinners and the die rolls? We'll also go over what those results showed, okay? Like, so if you flipped a coin 10 times and like that video we watched, you got like heads, 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 heads. You're like, what? That's not 50-50 chance. So we'll talk about what that means and what that looks like from your guys' score. All right.
There is a quizzes for today, and I'm going to be posting it in Google Classroom right after this. So please take that quizzes today.
Will you show that slide?
What?
That slide. One second, Manuel. So look on the screen now, guys. So this last slide here, here's some practice you can do to make sure that you're ready. If you haven't already done some of these. And then once you feel like you're ready, take the quizzes, and that's for a grade, okay? So make sure that you guys do that either today or probably tomorrow.
And if you don't have any questions, you're welcome to leave. We'll miss you. We'll see you Monday, 9 a.m.